Hello everyone. Today I am going to provide some information about our newly developed wireless data streamer. The title of presentation is a real-time sensory system to record and monitor humans' motion characteristics in physical rehabilitation. First, a brief introduction is given about the developed sensory system, followed by some examples of its applications and the specification of the development kit. I will then explain how the motion-related quantities are derived from the data streamer, along with the representation of the developed software for this product, and providing some conclusions about the wireless data streamer. What is Data RxW? Data RxW is the name of our sensory system developed as the result of a collaborative project between the Rehabilitation Technologies Lab and Titan Robotics Company in Winnipeg, Manitoba. It contains a wireless module to transmit data from the hardware to the software side. It can measure various physical quantities of an object, such as the human's body or human's hand, during the motion. The examples of physical quantities are three-dimensional accelerations, angular velocities, jerk values, and Euler angles, which are called roll, pitch, yaw. Data RxW has different applications in the health sciences and field of engineering. For example, it can be attached to a glove for the upper limb rehabilitation. It can also be used for research purposes on sport activities. And with respect to the field of engineering, this product can measure acceleration, gyro, magnetometer data, and Euler angles remotely and send them wirelessly to the operator's workstation. With respect to the specifications, the hardware part features measurement of up to 19 physical quantities with high accuracy. For example, the accuracy of the Euler angles is about 0.1 degree. The hardware system is equipped with an auto calibration and self-initialization procedure, plus a robust wireless data transmission, which can transmit data from a distance of up to, let's say, around 50 meters away from the operator's PC. In addition, there is a rechargeable battery system along with a power management system that can supply the required power up to 2 hours. The software developed for this data streamer provides the user with different features, such as real-time plotting of data, exporting the measurement data in Excel or text formats, as well as storing all graphs. The software is a cross-platform application that can be used in Windows, Mac operating system, or Linux. This is a representation of the overall procedure that is implemented to calculate and measure the physical quantities. As shown here, the calibration algorithm takes care of calculating and removing the offset and scaling the values of magnetic field data. In the initialization step, the gyrostatic drift is calculated and removed from the gyro measurements to avoid the accumulation of the bias over the time on the gyro data. After the calibration and initialization step is done, the three-dimensional acceleration, gyro, and magnetometer raw data are captured and converted to meaningful uh, data which are scaled and meaningful to the user. In the next step, the acceleration and gyro data are passed from a robust derivative algorithm to calculate the jerk and angular accelerations. In order to calculate the Euler angles, which are roll pitch yaw, we implemented a fusion algorithm. Before using the fusion algorithm, the orientation values are obtained from the combination of magnetometer and acceleration data. In parallel, another components of orientations are obtained from the gyro values separately. Then these two types of orientations are fused in the fusion algorithm to give us high accuracy measurements of roll pitch and yaw. In this slide, what you can see is a screenshot of the first window that pops up when running the application. Sorry. As shown, the user can choose three different operating modes named as AGM only, Euler angles only, and both modes. AGM only, AGM mode has lots of application in various fields of engineering. The user can also conduct calibrating and initializing steps by pressing the calibration button. We have two different versions of the software. In one of them, the calibration and initialization steps are done automatically in the software, and we in that version we have removed these two options from the software. After pressing the start button on the right top side, the data of the sensory system are captured by the application and are shown lively on the screen. Here you can see roll pitch, yaw as an example. The user can also select which measurements are needed to be monitored lively. This picture shows all 19 quantities measured by the sensory system, which are roll pitch, yaw, Euler angles, angular velocities, angular accelerations, linear accelerations, jerk values, and their magnitudes. A part of the application also provides some statistical measures obtained from the data. The current statistical measures that you can see here are the mean values, maximum values, range, sum, average, and the value of a standard deviation of each physical quantity. We have also improved the statistical measures in a collaboration with the Department of Statistics at the University of Manitoba, and new statistical measures are incorporated in the software. In order to export the data, the user can choose the desired format, either the text file or the Excel file. Sometimes after capturing the data, the researcher requires to have the original data for the further investigations. So this part of the applications provides all measured data that are already monitored lively for the user. Moreover, there are checkboxes beside each physical quantity, which enables the user to choose the ones that are needed to be stored. The user can choose all physical quantities or can select between them. This application has also been developed for receiving the data of multiple sensors, not only one sensor. So it's possible to connect even more than 5. We have actually experimented up to 10 sensors and connect them to the software, so the data of all 10 sensors can simultaneously be received by the software and can be stored by marking the checkbox beside the sensors. As you can see here, we have called them sensor 0, 1, 2, something like that. In the export window, the user can choose to export all of the sensors that are connected to the application. There is also an option for exporting the graphs with three different resolutions: HD, Full HD, and Ultra HD. This part is a cool thing that is done with by the actually software developers at Tactile Robotics company. As a conclusion, the this product data RxW is an inexpensive package affordable to research centers that comes with a small enclosure containing a wireless module and a small size battery system, which is rechargeable. The wireless module can reliably and efficiently transfer the data up to 50 meters away from the operator's PC. The power management system can provide up to 2 hours non-stop usage of this product. It can also measure up to 19 motion-related quantity, and the application developed for this data streamer enables the user to record and monitor the data for further research purposes, while they are able to see the data and motion components lively and in a real-time fashion mode. Thank you for attending my presentation. I would be happy to answer your questions, if any.
Thank you, Ali, for the presentation. It was very nice. Do we have some question in the chat room? Let me see. I
Should
don't
I?
see any.
I think I should. Yeah, it's good. Yeah.
Yeah, okay. We don't have any question right now,
Sandra,
so uh,
can I get one as usual? Like I have the veto here.
yeah, you can. I will ask mine after that. After you go ahead first.
Yeah. Okay, thank you. So thanks so much, Ali, for this nice presentation. I think it's very clear from development's perspective and product perspective. Um, I'm interested in two pieces, like how about the accuracy of the tool? This is first technical question. And the second one, maybe, I don't know if you can answer it or maybe one representative from the company. I see here Dr. Maddahi connected. So maybe to talk about the next step, which is commercialization or maybe the business model, how to deal with the researcher, how the company intend to deal with like business to business deals, etc. So maybe if you can take few minutes, if you have time, Sandra, please interact with that. So Ali, about accuracy.
Okay, with respect to the accuracy, as I mentioned, the accuracy of the, for example, other measurements such as acceleration, gyro, and magnetometer data are high enough, you know, and it can be compared with other even expensive available sensors in the market. We have done some comparisons, and but you know, it's a little bit intangible to talk about the, for example, the accuracy of the magnetic field in terms of Gauss or some other units. But to me, the tangible thing is the Euler angles, the angles. For example, if the data streamer is attached to the glove, a sensorized glove, so we will have roll, pitch, and yaw, and the accuracy of each angle is 0.1 degree, which is good enough for the research purpose. Even I think for some applications, even the accuracy up to 1 degree is enough. But it is more accurate than most of the available products in the market. Is that the answer that you wanted about the accuracy, or you need more clarifications?
I think it's okay for our audience. I received an email with another question from one of the attendees. He's asking about the dead zone for this product.
Uh, okay, same as other sensory systems. For the Euler angles, our implementation is actually, for sure there is singularity in the measurements, which is a mathematical thing, and it can never be avoided. For our sensory system, the we have no problem with calculating the heading and the rolls, but for the pitch, there's a limitation which is plus minus 75 degrees. It means that if the pitch angle increases more than 75 degrees, so we will enter that if it is called, I'm not sure if it is called dead zone or it's usually called singular area. So we need to apply some correction algorithms to take the measurements back to the correct values.
Mhm.
Okay.
Can
Thank you,
uh,
Ali.
can I add a point here?
Yeah, go ahead, go ahead.
Sure. I think that the beautiful part of this invention is the statistical software that we have. We had a collaboration with the uh, Department of Statistics here, and we have developed a very interactive software which gives you any parameter that you need. When you get the data, if you put inside this software, it calculates if the data is significant or not, or many descriptive statistics parameters, statistical indices that you may need for your research. It will give you. I would say this part of the software will give you the graphs that you need for a paper. If you want to submit a paper, write a paper, it gives you description. It gives you the graphs, beautiful graphs that you can include in the paper. And none of existing technologies, off-the-shelf technologies, actually have this software. And the price that you can find for other sensory systems is about 1,200 Canadian dollars, 1,200. The price that we consider for this is 800, considering including two software. One is one of them is an advanced statistical software, and I'm delighted to offer the attendees of this session, if they want this package from us, I would consider 50% discount for any attendee of this session.
Okay, thank you, Yasser, for your precision. We do have another question from Colin, but I think to keep the track on time, we will go forward from the other presentation. So I will thanks Ali again for his presentation, and maybe if you want to continue the discussion, move to a more private chat with Colin to answer this
Sure,
question.
sure.
So
Thank
thanks
you.
again.